Okay, for the question number 8, 8A1, figure 8.1 shows the electrical circuit. The resistor has a resistance of a 4 ohm. The reading on a voltmeter is about 3 voltage. Okay, over here, they are asking to calculate the current in the resistor. So here's a positive, here's a negative, and here the current will be flowing. Okay, it will be flowing and it will pass the diode. Okay, this is a diode. The function of diode is to allow current to flow in one direction. To flow in only one direction. Okay, so if you look at the diode here, this is a positive and this is a negative. So they will allow the current to flow in this direction. If the current is coming from the opposite direction, here it will be blocked. Okay, so the current cannot be flowing. So here we have a current, here is 4 ohm and here is a 3 voltage. So we can use this V equals to IR to calculate. We have here 3 divided by 4 and we can get the current. So the current value is 0.75 ampere. So this is the 2 marks question. Okay, so let us move on with the next one. Okay, now 8.2 shows the same circuit with the one component reversed. Okay, since here is reversed, okay, you can see that this is reversed. So when the current comes here, when they attach, it will be blocked. Okay, here will be current will be blocked. The current will be blocked. So what happened here? We don't have a current supply because it's already blocked. So the voltage reading will be 0 volt, and your explanation can be diode blocked the flow of current. Okay, the flow of current, so it's in a reverse direction. So this is your answer here for number 2. Okay, now let us move on with the next one. Okay, for this B, figure 8.3 shows the symbol of a logic gate. So these are the logic gate. Okay, this one is an N. Now they're asking, state the name of this logic gate. Okay, it's just an AND gate over here. Alright, now we move on with the next one. Okay, a student designs the circuit shown in a figure 8.4. So here will be, okay, so if you notice here, the gate here is a NOR gate, which means it's a combination of an OR gate plus with a NOT gate. So we can, in case you forget, we can do it from the very basic, the OR gate. Let's say here's AB, and here is the normal OR gate. Okay, the normal OR gate. So let's say I just make it here as a X. So here's X. So 0, 0, 0, 1, 1, 0, 1, 1. So OR gate means is either one. If either one of the input has 1, and automatically the output, which is the X, will become 1. So you got the 0, 1, 1, 1. Okay, now let's say if I put here the NOT gate, okay, it will become opposite. So it become, let's say I make it here Y. Here's Y. So 1, 0, 0, 0. So it is only will be on when the A, B, the input, both input is 0. So if you look at here, the C and D will share the same input and output. So here will be 1, 1, 0, 0, 0, 0, 0, 0. Okay. So now look at the E. Okay, E is the same, so not. So if it's a 1 1, so if it's a 1 1 over here, it shows is 0. Okay, you are getting here 0, and the rest is they are following the first one. So which is you are getting here 1. So here will be 1 1 1. Okay. Now look at this question, the last one for this part. Okay, a single logic gate can be used to produce the output E in the figure 8.4 with the input A and B shown in the table 8.2. State the name of this logic gate. So here it represents, if you look at this part, here, okay, so here will be the same, right? So it is representing the OR gate. So this is OR gate. So this is 1 mark for this, and total for this question is about 9 marks. Okay, now let us move on with the next one. Okay, question number 9. Electrical power is produced in a power station by alternating current generator. The output of the generator has a voltage of 22,000. The output is 22,000. The electrical power is transmitted at a voltage of 400,000 voltage. Explain why electrical power is transmitted at a voltage of 400,000 and not 22,000. Okay, let me explain this in a form of picture. So let's say the transmission system will be appearing like when you go to a highway. Okay, like you can see like a huge and you can see like sometimes there'll be like 4 wires, sometimes you have 3 wires over here. Okay, so normally the voltage over here will be very high voltage. Why high voltage is when a simple explanation here, when there is the current flowing in a wire, okay, you will have a heat dissipated around. You will be having a heat dissipated. Okay, when the current flowing, you will have a heat dissipated. So when the amount of current is large, so what happens? You will have a so let me write it down. When large current flowing, there will be a tremendous heat loss. Okay, so you can say heat loss, or you can say heat dissipated to surrounding. Okay, heat loss to surrounding. So how do we calculate the heat loss? We can calculate by using the formula I square R. Okay, these are the to calculate the heat loss. So how do we minimize the current? So we have to increase the voltage, because if you look at the power, because the transmission is they have to deliver the power. So let's say like here we have a 100 watt. Okay, so here we need to get at least about 95 watt or 100 watts the best. But normally we don't achieve the full power. Okay, because it will be there is a heat loss around because the copper, the cable here they are using aluminiums. Okay, so the power's formula is a VI. So when they increase the voltage, when they maximize the voltage, so what happened? The current they have to use is a very minimum. So when you have a minimum amount of current, there will be, you can cut down your heat loss. You can reduce heat loss. So that's why, that is the reason why for the transmission system they are using a very high voltage. Okay, so this is, I'm going to put in a words form. Okay, this is my suggested answer here. The first point is high voltage will result in a lower current. Okay, second one is lower current flowing in a wire will result in a reduced heat loss. Okay, sorry for my writing here. Okay, now your heat loss you can actually calculate by using this formula. Okay, when there is a large heat loss, so what happens is there will be a huge power drop at the output. Okay, so you can use your own words as long as you have these points. Okay, you'll be getting a 3 marks over here. Now let us look at the next one. Okay, a computer contains a transformer. The input voltage, okay, let me just draw a transformer here, a simple one. Okay, so it is made from a iron core. This part is made from a soft iron core. So just remember it. Is why they are using a soft iron core is to magnetize and demagnetize the magnetic flux. Okay, it can easily to magnetize and demagnetize. Okay, the input voltage is a 240. Output voltage of the transformer is 20 volt. So it's definitely a step down over here. Okay, it's a step down. So you can say here we have a lot of coils over here, and here we have a limited amount of coils. Okay, so here's about 240 voltage and here's about 20 voltage. Okay, now the output current here, output current that are flowing here is 2.3 ampere. Okay, the efficiency of the power is about 90%. Now they're asking the input current, so IP. So now we have to get the power. Okay, how do we calculate the power from this side? Okay, it's 5 marks question. Now we calculate the power here first. The power is calculated by VI. So which is about 20 voltage multiplied with 2.3, and you are getting here about 46. Okay, you're getting here about 46 volt. Okay, the formula for the efficiency is a power out over power in multiplied with 100 equals to 90%. So now the 100 we can move here, it becomes dy, so it becomes 0.9, and the input power is what we are going to find, and the output power we get about 46. So it's about 46 divided by 0.9 equals to power, input power. So your input power will be resulting in 46 divided by 0.9, you'll be getting here about 51 watt. So to get the current, so we can use the same formula as this. So P equals to VI, and the voltage here will be 240, and the power here will be about 51. So this is the current. So 51 divided by 240, we will be getting here about 0.21 ampere. Okay, these are the current, and this is how do we calculate this. Okay, so I hope you can understand this part. So it's a total about 5 marks only for this calculation question, and total for this question is about 8 marks. Okay, we move on with the next one. Okay, for number 10, figure 10.1 shows a relay. Okay, these are the relay, and the switch in the input A is closed, or the circuit A is closed. Okay, describe how this operates the motor in circuit B. Okay, so let me make it bigger a bit. Okay, so now the explanation here will be when you close this switch. So what happened? There will be a current flowing here, right? So when the current flows here, this rod, this soft iron core will become like a magnet. So when the current passes through the solenoid here will become like a temporary magnet. So when this one becomes a magnet, so what happens to the soft iron armature? So it will be attracted. So this one, remember, this is a pure, it's a fixed position. So when this one attracted to the magnet, all right, so this one will move up. So you will have a drawing Now let me just draw for you the rough picture of this. So it will become something like here. Okay, it will be attracted. Okay, it will be going up. Okay, so these are the second position of this soft iron armature. So this will move up. So when they move up, the contact here, it will be in contact. It will be closing the contact. So when they close the contact, what happened? Here there is a AC. So the current will flow through the circuit and the motor will be on. So this is how they will operate the motor. When there is a current, they opened in a circuit A, so they will lose the magnetism over here and the soft iron armature will return to the original point. So this one will be in an off contact. It will be open. So here there will be no more operating the motor. Okay, so this is the basic explanation of this diagram. Now let us answer the question. Okay, I have written here my suggested answer. Okay, when the circuit A is closed, the solenoid becomes magnet and attract the soft iron armature, which then close the contact in circuit B, and then current will be flowing in circuit B and operates the motor. Okay, so you can use your understanding to actually develop your own sentences and make sure you have all the points. Okay, the points are the solenoid becomes the magnet is the first point. You have to remember the first point, and it attracts the soft iron core. Second point, and third point is you have in contact with this one. Closing the contact is in number 3, and the fourth one, current will be flowing and operates the motor. These are the 4 points you have to mention. Okay, now let us look at the next question over here. The switch in a circuit A is open and the soft iron armature is replaced with a steel. Okay, steel armature. Okay, now the switch in a circuit A is closed. Okay, what happens if soft iron, if there is a soft iron, it's easy for them to magnetize and demagnetize. But if you're looking at steel, it's very hard for them to demagnetize and also magnetize. Once they become a magnet, it's quite hard for them to lose the magnetism and they'll remain as a magnet. Okay, this one is the characteristics for the permanent magnet. So what happens if you have a permanent magnet here? So they'll be forever in on position. Okay, explain what happens when the switch in a circuit A is then open. Okay, let me explain to you at this part. So what happened over here is once they on this, they will stick at the second position. Okay, even though here we open it, it will still remain as a second position because it's already becoming a magnet. So once it becomes magnet, the soft iron core and the soft iron armature here will be attached together. Okay, so here they'll stick because this one becomes a magnet. So let me write it down, my suggested answer here. Okay, the steel remains its magnetism even when there is no current in a circuit A. The motor in circuit B will not stop. Okay, this is my suggested answer. So it's 2 marks over here. Total is 5 marks for this question. Okay, now let us look at the next one. Okay, number 11. Figure 11.1 shows a beam of alpha particle, beta particle and gamma particle directed between the two metals plate P and Q. Okay, there is a beam of alpha, beta and gamma. Okay, so over here, the metal plates are parallel and there will be a large potential difference between them. So plate P is a positive and Q is a negative. Draw the paths of each of the radiation between the plates and after leaving the plates. Okay, label path alpha, beta and gamma. Okay, so for your understanding here, alpha is a 4,2 helium and it has a positive charge. Beta is a electron. Okay, it's a 0, negative 1 electron as a negative charge. However, gamma is a neutral. So you can see the gamma here, they will be traveling in a straight line. This one is a gamma. Okay, alpha is a positive. Okay, alpha is a positive charge. So alpha will be, okay, now I'll be using a red color line for alpha. Alpha is a positive, so it will be attracted to the negative. So alpha will be going in this way. Okay, so this is alpha. This one is alpha. And the beta I'll be using it in a blue color. So beta will be deflected here. This is beta. And you have to be careful at the deflection angle of alpha and beta, because alpha is much more heavier. So they have a lesser angle at this part. However, if you look at beta, they'll be having a larger angle because they are light. Okay. So this one, they haven't asked a question on the angles of deflection of a beta and alpha. So you can expect the question to be in a coming exams. Okay, so this is the 5 marks over here. Now the last one, state and explain one practical application of a gamma ray. So the application here we can say is a medical treatment. So the explanation here, it kills cancer cells. Okay, kills cancer cells. Okay, so this is one of the suggested answer. So this is 2 marks and total question is about 7 marks. So I think this is the last question for this this paper. So if you have any question, any doubts or anything, so you just can leave a comment below here and I'll reply to you. Okay, so thank you very much for watching this video. Please subscribe and like this channel. Thank you very much, guys.